Welcome to an athletic performance blueprint, measurement to mastery. This video explores the biomechanics, analytics, and protocols of the vertical jump, a fundamental athletic movement. The vertical jump remains the ultimate metric for lower body explosive power. It is the global standard in elite sports, serving as a core indicator of how quickly the body can produce maximum force. Maximum vertical height is achieved through the quote, triple extension engine. This requires a rapid, synchronized sequence of hip, knee, and ankle extension, driven by the glutes, hamstrings, quadriceps, and calves. Measurement can range from the accessible wall and chalk method to the Vertec device, the combine standard. The most advanced tool is the jump mat or force plate, which provides laboratory standard data like takeoff velocity and rate of force development. The baseline protocol involves 3 simple steps. First, establish your standing reach. Second, execute a maximal static jump and mark the apex. Finally, calculate the vertical jump height by measuring the distance between the 2 marks. To move from simple inches to advanced watts, we must calculate peak anaerobic power. This metric considers both body mass and speed/time, offering a truer reflection of power and athletic potential, differentiating performance beyond vertical height alone. The Sayers et al. 1999 formula is considered the modern gold standard for calculating peak power output without a force plate. It is the most accurate predictor of an athlete's true explosive power. These tiers categorize male vertical jump performance. An excellent jump is 28 inches or greater, which is the average NBA draft combine standing vertical benchmark. For female athletes, an excellent vertical jump is 24 inches or greater. This chart allows athletes to benchmark their performance against established athletic standards. Vertical mastery is a pyramid built on 3 pillars. The foundation is absolute strength, followed by plyometrics and rate of force, and finally, technique and recovery at the apex. The foundation of force requires raw strength. Aim to squat at least 1.5 times your body weight before heavily emphasizing advanced plyometrics. Heavy lifts and Olympic lifts build the necessary structural architecture. The stretch shortening cycle, or SSC, is where muscles and tendons store and release kinetic energy like elastic bands. Drills like depth jumps are catalysts that train the nervous system to quickly transition between absorbing and producing force. Optimized launch mechanics are critical. Stiff mechanics with tight hip flexors act as emergency brakes. Optimized mechanics use a proper arm swing and deep hip hinge, maximizing the load on the posterior chain for superior launch. Explosive power relies heavily on the central nervous system, which requires adequate rest. Follow the 48 to 72-hour rule between intense plyometric sessions to allow for supercompensation. Quality always supersedes quantity. The 12-week blueprint mandates that you must measure what you train. Establish your baseline. Combine strict strength training with targeted plyometrics, and respect the recovery windows to project a 2 to 4 inch improvement.